So welcome back, guys, of this 2011 integrated science past paper 2. All right, so I'll be starting back with number 5 here. It says, on a very hot day, the carpenter prefers to hold the nail with a glove made of thick cloth. How does the glove prevent his hand from being burned by the nail? So the answer is the cloth act as an insulator, right? Therefore, the gloves made of thick cloth absorb the heat from the nail but does not pass through it to the man's hand, right? So basically the gloves will act as an insulator, and once the glove act as an insulator, the heat will directly transfer to the gloves, but not the heat will not passes through the gloves to the carpenter hand, right? All right, guys. So that's how all of the energy transfer right there. All right. Anyways, number B right here. This bit giving me a little bit problem. Figure 4 is an incomplete diagram showing formation of sea breeze. So we have sea breeze here, guys. We have the land, we have the water, and it says what is meant by the convection as it relates to heat. So convection is a process by which heat is transferred through water. All right, so that's convection. All right, guys. It says indicate on figure 4 most likely direction of the airflow by placing an arrow at A and B. All right, so you just basically, they would say you have to indicate the most likely direction of the airflow. So you're just gonna either stick an arrow where you think the airflow would go, and it will definitely, the airflow from the water would go up, right? All right, all right. Sorry about that, guys. All right, this one number 3 says explain why the airflow in the direction that you indicate. So listen, the land heats up more rapidly than the water, right? As the land heats up, the hot air rises and cool air would basically take its place, guys. All right, over the water come underneath the warm air as it take place. The hot air moves over the water where it's cool and then travel down again over the land and replace as the air risen, resulting in a cycle. All right, so let me put it in a simple way, guys. When a hot air rises from the land, then cool place will take its place. All right, so once hot air go up, so we have a up and down arrow. Once the hot air go up, then cool place is gonna go down and take its place. So we have a reversal there. All right, go to another page. All right, so right here, guys. All right, sorry about that. All right, so figure 5a represent a circuit trees constructed to test the conductivity of various object in her home. Figure 5b shows how she connected the objects and be tested across the terminal X and Y with switch closed. Alright. So right here, guys, we have a figure 5a, we have an open circuit. Figure 5b, we have a closed circuit. And here it says consider the following list of materials. We have aluminum, carbon, copper, plastic, and rubber and wood. Alright. And one, it says choose two very good conductor. It's not says insulator, conductor. So for a conductor, we have copper and we have aluminum. All right, and it says choose one very good insulator. Remember we were saying insulator, guys. You could either choose between the rubber or the wood. All right, because the heat will not pass through those two things. And if it's electricity, the rubber will the electricity will not pass through the rubber as well. And for the hood, the heat will not pass through. So those are insulator. Right? B, it says if one dry cell provided a voltage of 1.5 volts, what is the voltage of the battery made up of 4 dry cells? Alright, so this is 6 volts, guys. Alright, It says what is the reading of the ammeter figure 5A? So right here 5A guys, as I said, we have an open switch and we have one. Let me see. Yes, we have the ampere. The switch is open. We have one, and if it's one per reading, it would be the reading will be 0 ampere. The A stand for ampere, guys, and the B stand for volt. All right. Number 3, it says, "Oh, will the value of the ampere reading changes when Cherise places a piece of conducting wire between X and Y." So listen, the ampere will now show 6 ampere. Why? Because the ampere, as you can see right here guys, we have an open, let me draw it down more so you guys could see. We have an open circuit, and once they place the wire across X and Y, then we will start our reading. And from our reading guys, as you guys could see, we have one, and we times it guys. All right, we're gonna times it by this, like this 1.5. You're gonna times that guys by this one. Sorry. Yes, so we're gonna times it and we're gonna get 6. So we basically would have a reading of 6 ampere. Alright. Number 4. It says when Cherise place a 2 ohms resistance between X and Y, the figure 5A closes the switch's voltmeter, right? And 4 volt. What formula can she use to calculate the current? Alright, so for current, as you guys could see, for current, we use the current as I, right? For we have ohmage right here, we have ampere, we have voltage for V, so we'd use voltage over resistance. All right. So as you guys could see, we have voltage, we have ampere, we have current, and we'd use voltage. This is mean divide, so it would be voltage divided by resistance. All right, guys. See if we have any more pages back. All right. Over here, it says, give one reason why it is beneficial to use a fuse in this circuit. And because the fuse is an electric device which protect the circuit from overload of current, that is why we use a fuse. If there's so much current passes through the fuse will break the current, right? If too much current is passing through. So see, Cherise has a radio. Sorry, just keep zooming out. All right, so Cherise has a radio, can be powered either by battery or electricity from mains. State 2 precaution that Cherise can take to prevent electric shock or fire when this radio is connected to electrical outlet. So first thing first, to ensure that the plug or the cord that is insulated does not have any, the wire does not expose, right? So for her to prevent the electric shock, make sure the wire doesn't expose. And another one, to ensure that the plug and her hands are not wet, because if her hands is wet and she touch the plug, then electrocution would occur, right? D, identify the most appropriate fire extinguishers to put out an electrical fire. So we use a class C fire extinguisher which had carbon dioxide, and the carbon dioxide now, it will basically, it's not really replace, but it will try to outwin the oxygen in the fire guys to get down the fire, right? That is why you use a class C fire extinguisher. E, it says name two items of the protective gears that firemen wear when fighting fire. So they use helmet and gloves. All right, guys. All right, I think we do this was ready. All right, wait, let me see. All right, no. So we have figure 5A, guys. I'll be stopping right here. I'll be doing part 3 of this video. All right. So with all due said, guys, make sure you guys do drop a like and subscribe to the channel. All right. So this is, I'll be finishing right here, and I'll be coming back with part 3 of this video. All right. So thank you guys for watching.